Hello students, let us review sound waves of class 11. We all know that wave propagation is nothing but transfer of energy, whether it is sound or it is electrical, or it is electromagnetic waves, or whether it is light. This is a transfer of energy. Medium do not get transferred, the energy is transferred by the means of medium. So the medium particles vibrate to transfer the energy. So let us see a wave. How, suppose here we are given a sound. So see this sound travel. This is I have shown here as a transverse wave, but sound is like this. Sound wave goes compressions and rarefactions. Compressions and rarefactions. So whenever there is a rarefaction, I am representing in this compression representing as a node. Node. This is antinode. Again, this is antinode. This is node. Let us assume. So we can represent both in a sinusoidal curve because it moves along sinusoidal variations with a perfect synchronization. So let us understand a wave. Suppose if a sound is given, so it has some this is amplitude. This is the amplitude. Here small sound, here higher amplitude, 0, then again higher amplitude. Like that, the amplitude varies along the from here to here. We call it as one wavelength. From crest to crest is one wavelength. From 0 node to node, one wavelength. You see here, these two are also same 0, but here it is going up. The wave is going up. Here the wave is going down. So they are not in the same phase. From here and here, as wave is going up, this is also going up. So they are exactly similar. So this is the number of. This is called time period of the wave. This is called lambda of the wave. This is called time period of the wave. In terms of time, it is time period. In terms of distance, it is lambda. Now, what is velocity? Is if this is lambda, say 10 to the 10 Armstrongs. Let us say this is 10 Armstrong. So, how many such lambdas are there? It is a frequency. What is frequency? In 1 second, how many such cycles are there? This is one cycle, so maybe 50 cycles. So once 1 second, 50 cycles will be there. So 50 into t. So f into lambda is the distance traveled in 1 second. What is velocity? Meter per second. So distance traveled per second. If you say lambda is in meters and frequency is per second, so this becomes f lambda is frequency meter per second. So time and frequency are one way. Suppose if I say from here in 1 second 50 cycles are there. If I put that in how much time it will take for one cycle. So this is one cycle. So it will take 1 by 50th second. So that is its time period. So t and f are related like this. T is equal to 1 by f or f is equal to 1 by t. So now free is number of frequencies. So now phase difference. What is the phase difference? Let us say it is at this point. This is phi. So what is this amplitude? Is not full, is not 0. So it is in between. So the phase difference says at what height that particle is moving. This is y. Let us say this is as y, this is as x distance, this is as y distance. So at a phase difference, this is 2 pi. Because by the time it repeats its cycle, 2 pi radians. From here to here is 2 pi lambda. 2 pi is covering lambda. So how much is covering by x? So 2 pi by lambda into x. This is its phase difference. 2 pi by lambda. So for a lambda distance is the 2 pi radians. And for x distance, 2 pi by lambda into x. X can be here, x can be here, x can be say one after any distance. But if number of lambdas it gets scored, then we get the, this is repetitive. This amplitude is repetitive to this point. This is continuously repetitive. So we will get a range here. So 2n pi plus some phi we will get for any distance of x. This is the phase. Similarly for time period. What is time period? For 2 pi radians it is t. 2 pi radians it is taking one time period of the cycle. So 2 pi by t into t, I get the phase. So phase can be defined as 2 pi by lambda into x or 2 pi by time period into t. Both give us the phase difference with respect to 0. Suppose 0 I am starting from 0 amplitude. the cycle start. Sine theta is 0, sine 0 is 0, so it is 0. So this is the phase difference with respect to distance, with respect to time. So everything comes between these 2 pi. This is 2 pi range. After 2 pi again sine value repeats. Sine 0 is sine 2 pi again, or sine it value repeats. So null to say. Sound waves are longitudinal waves and they need medium for transfer of sound energy. If it is in vacuum, sound cannot be transferred. So the frequency, what is audible frequency? 20 to 20,000 is audible frequency. Below 20 and above 20,000 we cannot hear. A normal human ear cannot hear. Now the velocity of sound in solid is more than liquid. So that is why a rail in a train, if you want to feel the train is coming or not, we can hear from the rail than through air. Even liquid, if you see the submarines, other things, the sound wave in liquid is faster than in air. So velocity through a medium, we have seen in earlier is elasticity by rho. We have seen in kinetics of these molecules, we have seen velocity by rho. When we have seen this is gamma p by rho. As a Laplace correction, gamma is p by gamma is nothing but Cp by Cv, adiabatic expansion. So gamma p is pressure by rho. This is the velocity in a liquid medium. Velocity in a liquid. What is velocity in a solid medium? Is gamma p by rho, because earlier Newton thought it is simply p by rho, but Laplace has corrected it as gamma p by rho. Okay, it is in liquids. The velocity of sound this through liquid, velocity of sound. Now velocity through medium is gamma p by rho. What is this p by rho? PV is nRT. PV is nRT. So P is nRT by V. If I put nRT by V, so V rho is mass. A mass by n becomes molecular weight. So gamma RT by m is velocity in the medium. Velocity in a medium. So suppose if I want velocity of sound through Y, so it is same P by rho. P I am putting A both sides. PA by A rho. So that means force by A into rho. So force is the tension in the spring. Force is nothing but the spring tension. The force in the, suppose if I hang the spring with mg weight, so force is mg by A rho. Rho is meter cubed per second. Meter cubed. A is kg per meter cube. This is meter square. So this becomes kg per meter. That means mass per unit length. This becomes mass per unit length. So force by mass per unit length gives the velocity through under root, gives the velocity through wire. So T by, that's what we call it as T by M. T is the tension, and here don't confuse with this T. This T is the tension. This T is the time period. Okay. T by mass is unit length. Mass per unit length. It is not capital mass, it is mass per unit length. So this is the velocity. So V in solids is gamma, this is rigidity modulus by rho. Here we have seen pressure by rho in liquids, pressure by rho in solids also, but sometimes it is rigidity modulus by rho also. So as P increases, rho also increase. So when P by rho, if I increase pressure, the density automatically increases because less volume is required for the same mass. So that means the velocity of medium is not affected by increasing the pressure. Increasing the pressure, but it is affected by temperature. It is affected by temperature. So when P increases, rho also increases. So velocity of sound remains same. So that is the reason if moisture is there in air, then rho reduces moisture because air is around 28 and moisture H2O is only 18 molecular weight, so it reduces, so density reduces, so V increases. So moisture air will travel sound faster than in dry air. Now you see here, a jet is going with a supersonic speed. Supersonic means around more than this. When it is going with supersonic speed, it makes so much of compressions that even radar cannot catch it, because radar needs the sound waves have to be reflected back. It will not be able to catch because it's going more than speed, more than sound. So the shock waves, this is creating a shock wave. This is a shock wave front. It creates a pressure in the front, and this is aftershock waves. in the rear side retraction. So here front side is a pressure, rear side is a retraction. So this causes shocks. So that is why shock waves are created in a radar. Let us see. As we have discussed, this is a starting point. The wave is moving forward. In a time t, it has come up to x distance. So x is equal to velocity of wave propagation into time, v into t. Okay. Now let us see. What is y at this point? This y is definitely the phase difference between one cycle. From here to here, if this is a cycle, so this is a phase difference. We have to see what is this phase difference. 2 pi by lambda into x gives us the phase difference. So 2 pi by lambda into x is the phase difference. That is what is called. It is the equation of this curve with this path wave is a is amplitude. What is this a? From here to here. This is a. So a varies as sin theta. A is increasing, reducing, increases as sine propagation. So a sine omega t minus kx is the wave propagation in the forward direction. If it is in the reverse direction, it is plus kx. It will be plus kx. In place of minus kx, it will be, because this point is appearing after a lapse of a time period t. That is why we put omega t minus kx in a forward direction. So what is omega? 2 pi by t. As I told, the phase is 2 pi by t into t. Similarly, in terms of x distinction, 2 pi by lambda into x. So k is 2 pi by lambda. Both give us the phase, so that the y of the particle at this distance can be asserted where it is at a or it is less than this. So as x is lagging in the initial position by kx phase, it is after k, it is come after the initial position. So we have put minus kx. Suppose now you see, when x is 0, that means here at this point, what is the phase difference is 0. So it's the initial point of wave. When x is n pi, that means it is after cycle. From here 1 pi, 2 pi, here it is 2 pi, it is 4 pi, these are the radian. So x is, if it is n pi, phase difference is 2 pi n. So again y is 0. If x is 1.5 lambda, this is lambda, 1 lambda. 1.5 means it's coming to here at this point. Here also 0, but it is going down. And 3 pi, the phase difference is 3. The y is going down. Going 3 pi means what? This is 2 pi plus another pi, 3 pi. So it is going down. It is going up, it is going down at 3 pi. So like that, the x value in terms of lambda, if we submit, we will get the exact location of particle y, how it is vibrating. Why we need this? Why all we are studying about why? Because when two when two sound waves are got imposed at a certain distance, they get superimposed. So at that time we know what is y1 and what is y2. The superimposition will give y1 plus y2. So to understand the concept of superimposition, we are studying the amplitude at different distance from the evolution of the sound. Okay. So suppose if the equation is given, I want to find out velocity of sound. So this is 2 pi by lambda, this is 2 pi by t. When I do lambda by t means f lambda. When it goes 2 pi, omega is 2 pi by t. And what is velocity? F lambda. This is k is 2 pi by lambda. So when I put the omega by k, what is happening? It is coming to f lambda. So the multiplication of t divided by multiplication of k, you will get the velocity of wave. So w by k, coefficient of t by coefficient of x will give us velocity of wave. So many problems are given on this basis. Equation is given. We have to find omega, we have to find k, we have to find velocity of wave, we have to find amplitude. All these things will come from the understanding of the equation. Okay. Now echo of the sound. See, our here is having persistence of hearing is 0.1 second. So light this sound travels at around 16 meters, 17 meters, 33 meters, right? 30 meters if I say, in 0.1 second it travels 33 meters. So if I am here go 16.5, come back, so it is 33 meters. So minimum distance for echo should be 17 meters. 16.2, 0.5 to 17 meters is the minimum distance. If I am nearby, I will not listen echo. That is why a big rooms where we don't have any material like sofa and other things, they get echo from the walls. If the material is there, it is fully filled up, they get absorbed. So the echo needs around 17 meters gap. Suppose say we are between two cliffs. Suppose I have not drawn here. Let us assume this is one cliff, this is another cliff. I am here. I gave a sound. So T1 is echo 1 plus T2 is echo 2 is equal to T3 for third echo. When I gave a sound standing here, so it goes up to this hill and come back. Let us say this is at a distance of 330 meters. This is at a distance of 660 meters. For understanding the case. So sound wave goes 1 second and touches, come back in 1 second. So it takes T1 is 2 seconds. I hear the echo in 2 seconds after my sound is evolved from this. Again here it is 660. So it takes 2 seconds up and 2 seconds down. It takes 4 seconds. So the second echo I hear it 4 seconds. So first echo 2 seconds, second echo 4 seconds. Now third echo. Whatever wave reflected from here, it goes to here and come back. So this is T2 seconds, T2 plus up and down T2. Whatever wave reflected from here goes here and come back, it will take T1 second. The third echo, I am going to hear that T2 plus T1, both. So third echo time is T1 plus T2. So this first echo is T1, second echo is T2, third echo is T1 plus T2. This is T1 plus T2. Both sides are T2 plus T1. So that is how we are going to hear echoes between two cliffs. Now we see the superimposition of waves. So this is a perfectly superimposed. If two waves are superimposed in a perfect phase, the amplitude of this phase and amplitude of this phase in same angle, and here are the nodes and antinodes are in same, so we get double amplitude. We get double amplitude. So if they are superimposed in pi, it's a pi phase difference. What is pi phase difference? This is pi. So when this is at peak, the superimposed wave is at minus peak. C is at peak, superimposed at minus peak. So the amplitude gets cancelled out. Amplitude gets cancelled out. So we hear zero sound. Here we see double sound. Amplitude is double. So we hear 4 times. Intensity is A square. Intensity is proportional to A square. So here 4 times sound. Here it is 0 times sound. Here again it is intermediate to 0 to 4 times. So that is how the interference of waves are important for understanding this wave nature. Okay. So similarly, what is beats? If two waves of nearby frequencies, suppose one wave frequency is 50, another wave frequency is 55, when they superimpose 50 and 55, two waves superimpose, then we get beats. What the frequency of beats is? 55 minus 50, around 5. So for every 5 frequency, 5 per second, 50 frequency means 50 cycles per second. This is 55 cycles per second. So I hear beats at rate of 5 cycles per second. So amplitude is maximum A1 plus A2 and the minimum is A1 minus A2, both. So this is the variation of the amplitude of the beats. So intensity is proportional to A square. So rise and fall of intensities is beat. What is a beat? Rise and fall of intensities. Number of beats per second is frequency is N1 minus N2. Let us say a standing wave. There is a string here, both ends fixed, and I provide a tension and release. So the string starts going up and down. Now that means what? Wave is going from here and being reflected like a hill. It is like a cliff. It getting reflected back. So when these two waves superimpose, what is happening? This wave going right side is Ya sin omega t minus kx. The wave coming in the opposite x direction is A sin omega t plus kx. When they superimpose, what we get? 2a sine omega t cos kx. So what is here amplitude? Sine omega t is the variation of amplitude, and 2a cos kx. 2a cos kx is its amplitude, and this is a variation. But it is a standing wave. It is fixed. It won't change. It can be with one string, it can be with two loops, it can be three loops. It is a fixed step. This is standing wave. This is what we call standing wave. So if there is only one loop between two, this is half lambda. You have seen what is full lambda? Full lambda is from 2 pi radians. It goes again the same direction. So from here, this is pi, 2 pi radians. So here it is half lambda. So in the first fundamental frequency, the lambda is 2L. This is length is half lambda. When 2 go to other side, lambda is 2L. So we know, we have seen velocity is root of T by M. Velocity is root of T by tension by mass per unit length. What is this mass? What is this tension? Tension in the string. So I can tighten the screws here. I can change the tension in the screw, in the rope or string. What is M? M is the string's mass per unit length. String is the mass per unit length of the string. So root of T by M gives the velocity of sound in this. When it is divided by lambda, we get frequency. F lambda is velocity, so F is equal to root by lambda. So lambda is 2L in fundamental frequency. So what I am getting? 1 by 2L root of T by M. What is I am getting here? 1 by 2L root of T by M is a fundamental frequency. In second, lambda is L. In third, lambda is 3 by 2L. In fourth, lambda is 2L. See, this is 1 lambda, this is 1 lambda. So L is 2 lambda. L is 2 lambda. Here L is 1 lambda. Like that, if we convert to lambda, lambda is L, lambda is 2 by 3L, lambda is half. Like that, we get other overtones. This we call fundamental frequency. This is first overtone, the second overtone, third overtone. If it comes to harmonics, fundamental frequency is first harmonic, second harmonic. So first overtone is nothing but second harmonic. So in terms of harmonics, if you see first harmonic, second harmonic, third harmonic, fourth harmonic. In terms of fundamental notes, fundamental note, first overtone, second overtone. This is the nomenclature between tones, overtone and harmonics. Let us understand. Okay. So fundamental frequency is 1 by 2L root T by M. What is this frequency? Here lambda is 2L. So 1 by 2L becomes 1 by L. 1 by L root of T by M. That means 2 times of F1. 1 by L means 2F1. Similarly, F3 is 3F1, 4F1. Like that, we have the frequencies, we have many overtones are appearing. Same string. So please note that the standing waves, the energy is not lost. The waves are in standing waves. This is a standing wave with a lambda. So this is how in a Bohr's orbital model, the electrons are moving around nucleus in a fixed 2 pi. In the lambda is this orbital, lambda or n lambda is its orbital length. Then it became a standing wave. Suppose electron starts from here, move around nucleus and come back. This is the length. If it is lambda or n lambda, this is not losing any energy. Otherwise, the in between orbits, in between electrons, they have vanished. They didn't stabilize. Energy is lost. But what are the things stabilized? Is those orbitals have survived with the standing wave perimeter of the orbit. That is what it has come from here. Okay. Now let us see the vibration waves in argon pipe. This is open argon pipe. The open argon pipe means both ends it is open. Open means antinode. In between we have node. Whenever there is an open, we will have an antinode. Here amplitude is maximum. Here amplitude is 0. If you see the pressure, if you see the pipe pressure in the pipe, here pressure is minimum because it is expanded. Here pressure is maximum. So the air here is maximum pressure, air is minimum pressure. So it is in the argon pipe, this is a fundamental node, it can come. It is almost same. See, it is lambda, here also lambda, but here node is between, antinode both end. Here node is at the end, antinode center. So this is the fundamental frequency. This is again lambda is 2L. Similarly here is lambda is L because it is lambda. From here coming up, coming down, again repeating its cycle. So this is lambda. This is exactly if I open end, both end open, and the string closed end both are same. So here also we'll get all the frequencies. All harmonics are present. That's what we call it as all harmonics are present. First harmonic, second harmonic, third harmonic, all are present. If you see the one end closed pipe, one end closed means here it is no, here it is open. If you see the pressure, inside air pressure, here it is minimum, here it is maximum. So once I set the vibrations in this pipe, how the air behaves, this is lambda by 4. This is not even lambda by 2. This is lambda by 2. This is lambda by 2. This is lambda by 4. So lambda is equal to 4L is the first hormone. In the second hormone, how much it is coming? Lambda, how much is coming? So first overtone or second, in the third harmonic, lambda 3 is 4 by 3L. See here it is how much? This is 3 by 4 lambda. This is half lambda. This is 1 by 4 lambda. So total is 3 by 4 lambda. So 4 by 3L. 4 by 3L. Here how much is getting? Lambda 4 by 3L. 4 by 3L means 3F1. 4 by 3L means third harmonic. First is lambda is 4L. So if I put root of T by M in the formula, so 1 by 4L root of T by M is a fundamental frequency. Next comes 3 by 4L root of T by M is the second one. So 3 by 4L means what is this? This is 3F1. So like that I have got only 3F1, 5F1, 7F1, like that only odd harmonics. These are all odd harmonics. This is the first harmonic, this is the third harmonic, this is the fifth harmonic, like that odd harmonics. If I see in terms of overtones, this is the fundamental frequency, first overtone, second overtone. So you understood now, overtone is immediate one, over and above first fundamental frequency. But harmonics, they are fixed. First harmonic, second harmonic means is double of 2F1. But here second harmonic is not, even harmonics are not present here. Only odd harmonics are present here. Okay, this is a closed pipe, this is an open pipe, this is a string closed at both ends. It is almost equal to closed at both ends. This is a system of closed at both ends. Now, in the pipes we have end correction. It is exactly not antinode here. Antinode goes somewhat slightly higher. So the end correction is given as L is equal to 1 plus E for one end closed. L plus E. See, this end is closed. Here there is no need of end correction. Only one end is end correction. If both ends are open pipes, you need 2E. So E is approximately 0.6 R. R is the radius of the tube. We can find out from experimental also. This is what a resonance tube. If I put a fork here, if I length water level to this point, I'll get fundamental frequency. Then if I reduce water level here, what is frequency means? I will hear a loud voice. Suppose when the wave is cut and come back, I hear a loud voice here. So again, at this level also I am hearing a loud voice. At this level, if I give water level, I hear another loud voice. So like that, if these are the different levels I observe. Suppose the first one is fundamental frequency. This is lambda by 4. So lambda by 4 is equal to 1 plus E, L1. This is length 1. Length 1, and we have some correction which we are yet to find out. L1 plus E is equal to lambda by 4. Similarly, when I come here my water level, I will hear another sound. So this, what is this length? 3 length. This is lambda by 2 plus lambda by 4. Total 3 lambda by 4 is equal to L2 plus E. Similarly, L3 plus E, L4 plus E. When I resolve this, I get E is equal to L2 minus 3L1 by 2. This is L2 minus 3L1 divided by 2 is, suppose these two I am eliminating lambda. This is 3 lambda by 4. I multiplied 3 lambda by 4. 3E, 3L1. So these get cancelled. 3E minus E is 2E. And this is 3 L2 minus 3L1. L2 minus 3L1 by 2. This is E. Similarly, we get V also, F lambda. Frequency we know because of the tones what we have used here. we know its same frequency, the air is oscillating. So we can get, this is the resonance tube experiment. Now we have Melde's tube experiment. Here what happens, this tongue is there. This string is connected to the tongue. String is connected to the tongue. When I supply an AC voltage with some frequency, so this is a solenoid, it gives connected to the string. So this string starts oscillating. Plus minus, suppose if it is plus minus 50 cycles per 60 cycles per second, it will also plus minus, so it will oscillate. So similarly the string also oscillate. So it is a longitudinal arrangement. The string, the tongs is oscillating in the direction of the rope. So we'll get two, when it oscillates two times, it will oscillate one time. So this is called 2f of string is equal to 1f of this mode, strings mode. In the transverse mode, what is happening? I have given here the string is connected. So if this string is moving up and down, same number of frequency also it makes up and down. So ultimately the F string is F4 in a transverse mode, and in a longitudinal mode, a 2F string, 2F strings is 1F, 4 chord tongue. So if the number of loops are P, so loops are P, that means what? P by 2 is lambda, 2P is lambda. So P by 2L is the lambda into root of T by M. If I see this, P square by T is constant. What is this? What is this formula? When I say f of string is P by 2L root of T by M. P by 2 means each lambda is P by 2. This lambda is L by 2. This is length of the string. What is this? This is lambda by 2. So lambda is 2L. So when I see number of is P by 2L is a total like this into root of T by M. So if I remove the square, what is happening? P square by T. P square into T. So the f of string is fixed. The f of string is fixed. So P square T is constant. That means if I can vary load here, I can vary with different loading, I will observe that the number of this P means what? Loops formed are in the ratio of P square T. T is increased, T will reduce. If P is increased, T will reduce. P is the outcome, T is the cause. So we can do this experiment with known frequencies. You can change the frequency also. So we can do this experiment. So what is the energy of wave? Energy of wave is half m square, velocity, mass. So if I say energy density is energy by unit volume. If I put unit volume, m by volume is rho. So that is half rho square. What is velocity? Velocity of this is a omega. Here the velocity is a omega. We have seen in amplitude a omega. If this is the y is distance, if I do it dy by dx, a omega sine omega t cos omega t plus y. So a omega is the velocity. Dy by dx is the velocity in the y direction. So a omega will be the maximum velocity. So that means half rho into a square omega. So that means what? The intensity is energy into velocity. This energy density into velocity of wave. So half rho c a square omega square. C is velocity of wave. This v is the particle velocity, the vertical velocity. This c is wave velocity. So c is velocity of wave. So So I is intensity is the energy per second per area. Energy per second per area. So when I C means meter per second, V is meter cubed. When I do this, I will get energy per meter square per second, that is intensity. So from this equation we observe that intensity is proportional to amplitude square. What is the intensity is proportional to amplitude square. Frequency is nothing but a measure of pitch of the sound. Now we will see Doppler effect. You see Doppler effect. Suppose this is a source of sound coming. It has given a whistle. The sound waves are moving like this, same way. But if the source is also moving, what happens? The velocity of source will, there are more number of lambdas, more number of this covered because of this velocity, they get compressed. If this is observer, this is a source coming with the velocity, so more number of lambdas, more number of peaks are covered in this. Earlier, this is, if it is not moving, this is the frequency. If it is moving, so more number of waves are, so frequency has risen. Frequency has risen. That is why we hear, when we stand here, train is coming, we hear that sound is increasing as it approaches. It leaves, sound is decreasing. But its sound is same, only because the source velocity is adding to its sound. If you see the, in place of source is coming, suppose observer is moving. Same case here, source is moving, now observer is moving here. If observer is moving, there is no compression of this. Only thing is, he is covering more lambdas. Observer is covering more peaks in the same time. But here, it is more, these are appearing in the source moving. So, source moving is a different phenomena, observer moving is a different phenomena. That is why the equation has come, apparent frequency is equal to frequency of original, whatever visual frequency, original divided into V plus, suppose observer is going towards it. So V plus V observer divided by V minus V source. Source is coming, observer is, both are going opposite to each other. They are closing each other. In that case, V plus V observer by V minus V observer. If it is going opposite, if his observer is going opposite, so it becomes V minus V observer. If the source is going opposite, so V minus V source. Out of these four only it moves. Whatever may be the combination, these are the rule. If the observer is on the top of the equation and source movement is on the bottom of the equation, numerator and denominator. So the difference is here number of compressions are more, here he is covering more. Compressions are same, but he is covering more. So V plus VV or V minus VV, the relative velocity. This is the relative velocity. This is the velocity, relative velocity of sound with velocity of source. So this is the equation. So apparent frequency is equal to fundamental frequency, whatever frequency the sound is coming, V plus V observer, V plus or minus V observer by V plus or minus V sound. Plus means relative velocity is less, just more, minus means relative velocity is less. So if you see here, universe is continuously expanding. How we can say that, suppose we are here and one star is going away from us. So what happens when it's going away from us? The apparent frequency of this light, whatever it is emitting, is this side is more frequency, this side less frequency. Since it is going away from us, so its side is, it becoming less frequency, it is enlarging, it is compressing. So this side is violet, this side is red. Less frequency is Vip jar. Vip jar is the higher, red is having higher wavelength. That means less frequency, less energy. So this is called the planet, the star appears red. Red means from it can, suppose if earlier it is looking for blue, Vip jar, it means indigo. Like that, it will cover from violet, it moves to red. This is called red shift. This is called red shift because it is moving away from us. This is the Doppler effect in light. This is the Doppler effect in light. What is the formula in Doppler effect in light? Apparent frequency is the light frequency. Frequency of apparent frequency is light frequency is equal to velocity of light plus velocity of source divided by velocity of light minus velocity of source. Here there is no observer velocity. Observer velocity is almost zero because compared to light velocity, observer velocity can be neglected. So with the light velocity itself, it is apparent which is square root of C plus V by C minus V source. So this is the Doppler effect in light. If source is moving faster than sound, it produces shock waves as we have already discussed. So due to expansion of waves leaving behind and due to compression of waves in front of it, there is a pressure difference. Here it gets expanded, here you see, here it is expanding, here it is compressing. There is a here high pressure, low pressure. So these shocks will come. Like that here also shocks. These are called shock waves. So in a transverse effect, let us see what is in transverse effect. Source is moving like this and observer is moving like this. What is happening here? source is moving in this direction, vision source, and observer is moving in this direction at any random direction. So what is the relative velocity? What is this observer's velocity in the direction of source? V cos theta. Here it is V cos theta. Here it is V sin theta. Because the source, it is the source is producing same lambda, but it is getting compressed here, it is getting expanded here. So if you see apparent frequency by the observer is V is the source plus V0 cos theta by V. Because source relative to the observer is 0. So there is no V minus V source. This is going perfectly 90 degree. But he is having some component towards, this is V cos theta towards X component. So observer is moving V cos theta. Source is not moving this side, is moving perpendicular. So relative is 0. So that is why we call V plus V observer relative V observer divided by V of the source. This is the apparent frequency in transverse directions. So like that any direction we can see. Let us say this is a traffic police camera, this is a road and vehicles are moving. We want the speed limit is say 80 kilometers per hour. So how the instrument is going to find out whether this car is going with 80 kilometers per hour or not. So this is the left side, no? So it may be going this side, what direction it take. Then what it will do, he will send a signal, send a sound signal. So if the speed of the car towards with respect to him, what is its speed of the car? V cos theta. V cos theta. So the reflected frequency is increased by this V cos theta effect. So the apparent frequency is V by V minus Vs cos theta. This is a source is moving. So it is coming, it is getting to, once it reflected, this becomes source. It is sending, this is source, it is getting reflected by this, means this is the source. So this is the V minus Vs cos theta. V by V is the velocity of sound and V minus Vs cos theta. Vs is the our car velocity and its velocity relative to this instrument. So the frequency we know, this frequency we know, this frequency is observed by the instrument by the time it receives. So we will find out V cos theta from the mathematics. So instantly the instrument will understand that this vehicle is moving within the limits or more than the limits. Okay, this is a system. So approaching frequency is V by V minus Vs cos theta. Approaching means it is V is towards it. Receding is going away from the FO by V plus Vs cos theta. The velocity is going away. So frequency will be reduced. Here frequency is increased like a train moving and standing observer. So but basically this is the principle of finding out the speed. Now we have earlier discussed that sound velocity varies is more in solids. You see steel it is around 5,000-6,000 meters per second, but in air 330 meters per second. So how difference? That is why people put their ears to the steel rails to hear whether a train is coming or not. Because this is the difference, almost more than 15 times, 16, 17 times it is more. Okay, so that is why this will give an immediate this that whether train is coming or not well before in the air. These are the different properties of sound. Longitudinal natures need material, it can be reflected, refracted, they get absorbed. All the properties are even read out. Get absorbed in the medium. So now you see the two waves are superimposing. Two sound waves are superimposing. This is a sound wave. This is another sound wave. They imposed at this point. So what is the resultant? If I shift this wave, this we have already discussed earlier how to add vectorially. This wave is shifted here with the same theta. Then what is the vertical portion of this? Is A2 sin theta. And what is this horizontal length? A1 plus A2 cos theta. This is what is delta. A2 sin theta by A1 plus A2 cos theta. This is tan delta. This is what is tan delta is A2 sin theta by A1 plus A2 cos theta. So what is the resultant? Resultant we have seen the cos formula. A square plus B square plus 2AB cos theta under root. So we can find out what is A of the interfered sound. So we know intensity is 4A square. 4A square cos, it is cos square 5 by 2. This is the, what is this phi? Phi is the angle between the two waves superimposing at this point. This is the phase difference. This is the phase difference between the two waves superimposing at one location. So we will 4A square cos square 5 by 2 is the intensity of the sound when we superimpose. Now we'll go to what is pitch? Pitch is sensation which determines the shrillness of the sound. It is subjective and cannot be measured quantitatively. It depends on frequency. If frequency is more, its pitch is more. What is quality? Quality means, suppose we have seen here, whenever there is a sound between when the vibrations are there, it can be associated with other frequencies also. This is fundamental. These are first harmonic, second harmonic, third harmonic. If the more number of harmonics means it is more disturbed sound. If these harmonics are removed, if only get one sound, we'll get a very clear timbre quality sound. If harmonics are mixed, then we get a disturbed sound. There is a quality of the sound. Distinguish between two notes of same pitch and loudness produced by two different sources. Basically, it is superimposition of the harmonics onto the fundamental. Now, how the loudness is defined? This the loudness is defined as log I is in the logarithmic scale, log I by I0 base 10. Loudness is defined as K log I1 by I0. You see here K is 10 I am taking here. So I is dB decibels. This is in the terms of bell, decibel, like that. Deci, deca. Deci means 10 to the power minus 1. Decibel. So decibels. So 10 log I by I0. How I0 is defined? Either it can be a power of 1 into 10 to the power minus 12 watt per meter square in terms of energy. In terms of pressure, it is 2 into 10 to the power minus 5 pascals. So the I0, this is the smallest sound we can hear. This is the smallest sound other than 0 we can hear. So this is taken as base of the sound, 2 into 10 to the power minus 5 pascals at a distance of 1 meter. At a distance of 1 meter from the source. So this is the pressure of air at that point, developed due to because of the sound, and this is the intensity, is the power, 1 into 10 to the power minus 12. So if the other ice, whatever we are receiving, when we do a logarithmic scale, we will get the what is the decibel sound. If we give some of the decibels here, a near whisper is around 15 decibels. Normal we talk to each other 60 decibels. My sound is slightly more than this. It may be 70-75 decibels. A lawnmower 90 decibels. A car 110 decibels. Our allowed internal standard is 90 decibels. If more than 90 decibels, our ear may get prolonged. If we subject to prolonged this sound, ear may get defective. So maximum 90 decibels is allowed. So 110, then we have jet engine, then a gunshot, a firecracker is 140 decibels. So how do this is 140 decibels a firecracker. So the definition is logarithm scale. This has been defined. That means if my sound is 10 times more, it is 10 decibel. If it is 100 times more than the minimum, it is 20. If it is 1000 times more than the minimum sound, which is 30 decibel. Like that, it is in a logarithmic scale. Okay.